And then what comes after the then part of this is what you're being asked to prove. So if you want to, you can actually write this out as given CD is congruent to EF. This is our given information. Then we want to prove based on that Y is equal to 8. And again, notice that we're going from having congruence in our given to having an equal sign in our proof. So at some point I'm going to have to change from congruence to equality. Let's go ahead and set up our 2-column proof. Just like so. Statements on the left and reasons on the right. As always, our first statement is going to come from the problem, whatever our given information is. In this particular proof, this is all the given information that I have. Segment CD is congruent to segment EF. The justification for this is that it was given to us. And like I said, at some point we've got to go from congruence to equality, and that's going to be immediately in step 2. If I know 2 segments are congruent, I can also say that they are equal. Okay? And this is the definition of congruent segments. Okay? Very similar to using the definition of congruent angles in my last proof. Okay? So now that I know, and this is the same thing as before where I went from congruence to equality, now what I'm saying with the equal sign is that the measure of this segment is equal to the measure of this segment. Okay, well, I have some expressions to represent the measures of those segments. So for my next step, I'm going to replace the measure of segment CD with its equivalent expression. I'm going to replace the measure of EF with its equivalent expression. And when I substitute an equivalent value, that is the substitution property. All right, and from here on out, this is going to be an algebraic proof. Okay, so my next step, I would be adding 9 to both sides to get 3y is equal to 15 and 9 is 24. This is the addition property of equality. My next step would be to divide both sides by 3, and that would be the division property of equality. Okay. And always go back, look at your last statement, and look what you've been asked to prove. Okay. If those 2 things match, then you're good. If they don't match, then you need to go back and see where you went wrong in here, or you're not done with your proof and you need to keep going. Okay, so we've kind of merged our algebraic proof with geometric concepts. We'll continue our discussion on this tomorrow. We'll do some more algebraic proofs together. We'll do some geometric proofs on, algebraic proofs concerning geometric concepts together also. And depending on how that goes, we may or may not get to proving lines parallel. Go ahead and make sure that you take your Socrative quiz so I can see those responses, and that will give me a good starting point for tomorrow. And I look forward to seeing you then.